On this session, what we'll cover how easily that you can convert your Inventor files, could be native and both non-native, to NC1 files, right? My name is Mahbub Rahman. I've been with the Structural Solutions for the last 9 years, and I'm helping my clients worldwide to convert their CAD files to NC1 to send it to their machine almost seamlessly. After this session, I think you will have a better idea how the software actually works, and you will understand the workflow involved to batch process even and assembly components to NC1 files. Okay, so what I'll go through is I'm going to go through a few of my slides over here, and I will try to explain how the software behaves, and then we'll jump in a couple of examples that I have on the Inventor platform. And what I want to do, I want to conclude that session within 45 to 50 minutes, and then I would like to hear questions from you, gentlemen. And if you have any question, then I'll be happy to answer those questions at the end. So just a quick portfolio about our CMS solution line here. We support both Inventor and AutoCAD. Inventor and SolidWorks when it comes to 3D modeling. If you want to work with 2D drawings, both DWG and DXF files are converted directly from your AutoCAD platform. And if you're using MBS software, then we can convert your DXF files, batch process them actually, and convert to NC1 files. On top of that, we have a standalone solution that we call CMS Standard. So you want to create anything from scratch. So for example, you want to go and create some a BIM from scratch, right? And then you want to apply some miter, some copes, and also apply some drills. Then you can create that without modeling them on a CAD platform. So you can put some instructions on the CMS Standard, and then you will have your NC1 file ready to go. On top of that, CMS Standard can also edit your NC1 file. So if you have any corrupted files, let's say for example from Tekla or SDS2, you have those files and your bevel descriptions are wrong in most cases. And if you want to clean that up, you can delete the existing ones and you can apply the new ones. It's very straightforward. And I plan to show you an example at the end of this end of our session. Integration-wise, the machine type-wise, we actually work with all major players in the market, and and our NC1 file is working fairly smoothly on those machines. But the bottom line is, as long as your machine supports the DSTV standard, then our NC1 file will be able to work with your machine without any issues whatsoever. So from the name, it's very obvious that we're going to work on your native Inventor models. On top of that, as we mentioned in the very beginning, that we can support on non-native Inventor models as well. So if you have you're getting anything from your client or your supplier, or from your design team, you're getting some IGS files or step files or set files, right? And as long as you can open that in the Inventor, both your so if it's an assembly content or a single member, so we can convert them as well, right? The extension of our file that will be saving as would be .nc1 file, right? And we strictly follow the DSTV standard. So as you probably already know, the DSTV is a German Steel Association Construction Association standard, and that's been adopted by almost all over the world internationally, right? So again, it goes to the bottom line, any machine that supports the DSTV standard will have no issue whatsoever compatibility-wise with our NC1 file. We'll strictly follow the DSTV standard. So either you need a DSTV file, that people call it DSTV file as well sometime, and either an NC1 file at the end of the day is the same file, right? For the folks who are new in this area, just wanted to give you a quick rundown about the DSTV file config. So as you know, DSTV is just a file format, either it's an ASCII format or UTF-8 format, and you can open that with Notepad. And as those files are very straightforward, honestly, very easy to understand and talk about the operations. That is almost self-explanatory, right? So the software comes with a few header lines, and then well, normally it starts with an ST command, and ends with an en command over here, if you can follow my cursor over there. In between, as you see, this highlighted portion is the header data, and some of the gray lines over here that you see here, some of the lines that we can map from your I properties. So we are talking about the Inventor. So if you have any I properties that you want to bring into those header lines, some of the machines really want to see those lines, and some of the machines don't care at all. So it's solely up to you and your machine config, right? Anyway, other than that, like, you know, operation wise, and you know, if you have any operations that have to do with external cuts, like, you know, your miter, your cope, you know, and bevels, you know, they will come like, you know, directly from your Inventor model, right? You don't have to do any pre-processing or post-processing to convert those details to your NC1 files from your Inventor model. Same goes for your openings and cutouts, right? Anything that you have there. If you have slot and holes, they will come as a BO block references. It's not block reference, sorry, it's a DSC block, right? If you want to stamp your part number, either you call it etching or scribing. You know, people also call that etching and scribing for the stamping, the part, like, you know, stamping the part, right? Not necessarily the stamping, but it's like, you know, it might etch your part number as well. So we can do that as well. So we can read if you're using embossing feature, for example. So as you know, like, you know, you have an emboss feature within the Inventor platform that you can put a text, right? So we can grab the text from that embossing feature, or we can just stamp your part number on a default location of your choice. So you can define, like, you know, where do you want to place it, like in which face. For example, the best practices would be top flanges, right? So you put your part number, for example, if you have that part number on your I properties, we'll grab that part number details from the I properties and read it from there and put it on your top flange on a defined default position. So, you know, you're going to give, like, you know, exactly where that you want to see them. So if you put those values in XY quotation values, right, then on that exact point, the software will place your marking. I mean, not marking, I meant text stenciling. So it, you know, sometimes people call it scribing as well. Anyway, on top of that, if you have to do marking lines, so like, you know, there's two different things. Like, you know, if you want to put anything text-wise, we'll bring it as an SI. But if you have any kind of lines, right, those will come as a KO block. So the software can also recognize those. Any kind of unused sketches and the sketch that not been consumed that you want to bring it as a marking content, you know, we can bring that directly from the model as well. If you're working with sheet metals, we do support sheet metal as well. So and then the machine is capable with handling with the bending operations. If your machine can support that, then, you know, here you go. Like, and we can give you those DST block as well, right? So I will have examples for all of those cases in my coming you know, Inventor session. I mean, like, you know, I'm talking about like putting up some of the examples on my Inventor platform. I'll show you almost all those scenarios. To sum up again, like, you know, what the software can do, well, it can definitely work on a single body part. So I'm in part level, right? So at the end of the day, you really have to remember that, like, you know, when it comes to the part level, we want to see that like, you know, you have like, you know, unique body on a model, right? Like, you know, let's say, for example, if you are drawing an I-beam and you want to put your end plates on the same part of it, the extrude, that's not going to work, right? It's like, you know, those end plates have to be separate IPD files, right? That's just a you know, quick example. We work on assemblies and sub-assemblies, right? Given that, like, you know, everything that you see on this on an assembly or sub-assemblies, and at the end of the day, every component is a single body, right? Additionally, as we mentioned, like, you know, we can do non-native Inventor models as well, as long as you can open them with Inventor, right? Without any pre-processing, all you do, you open them and, like, you know, save it. Like, you know, Inventor will automatically save them as an IPD file or an assembly file, IAM, and then from there we will be able to convert those files fairly quickly. Just a quick advantages I mean, it's like, you know, I'm gonna say it's like, you know, a very quick you know, advantages here is, like, you know, system wise, you don't have any requirements. So as the software runs as a plugin within the Inventor, you can keep your current access control. Like, if you're working on a strict environment, then you can still keep them as it is. The license-wise, software works on a lot of web-based licensing system, and as long as you're connected to internet, you should be able to have access your license from anywhere in the world. So if you're using a floating license, for example, and you want to share that license with your other colleagues, or you want to share with your other workstation, then you can easily achieve that. But our standalone licenses are very specific to the machine, so it's a machine-bound licenses. So if you want to move between workstation, then you have to move on to our floating license options. So let's just move on to our Inventor platform, right? So the first thing that I'll do, I'll start with the part scenario, right? So once you go and install your software CMS, you're definitely going to see that's the CMS tab popping up here, right? And it will have different tabs, right? The first thing definitely we'll have to do is train the software and give you some let it know some basic information that will be harvesting from my properties, right? So the first thing that I'll do is and I'm going to click on CMS settings, and just to let you know, you can name your file, your NC1 file in few options there, right? The preferable way would be grabbing your part number from your iProperties and save it as part number.nc1, or if you want the document name from there, right? Like the name of the file itself. If you want that, then you can choose that one as well. I'm going to be sticking to the part number for my entire demo here. And at the same time, if you're working with on an assembly and you want each and every components, if you're working on an assembly, you might have multiple occurrences, right, for a single part, right? And if you want to capture all those occurrences, patterns, right? If you want each and every components to be present on your NC1 file, so for example, you had, for example, if I just come over here, I'll just open an assembly over here quickly over here. So if I just zoom in here, right? So as you see, these are the same few pattern here, right? Instead of three separate NC1 file, if I want one, I'm not going to go with the option for the settings on the component occurrence. So what I meant by that is if you choose that option, so the software will bring multiple NC1 file for each and every occurrences. Okay, and the last option is dynamic naming convention. So what we do is as we mentioned in the very beginning, is we can read your iProperties from your Inventor, right? So to access those iProperties, you have to be on the part level, right? So I'm just going to get out of here and go to a part again, right? And then click on settings one more time and come back to my property links. So as you see over here, it's listing all the properties that is available on that part, right? Including your custom. If you have any custom properties, then it will also show up over here. And then, as I said, you want to map some of the data based on your CMS, not CMS, is based on your machine expectation. So some of the machine really don't care on those lines, like for header data, and some of the machine has very specific need for those lines. So if you have to do anything, for example, you can just drag and drop it, right? Let's say, for example, let's say I want my revision number actually on line 2, right? And I want the description, and then on line 4, I have seen and some of the machine also wants the part number repeated information on the line 4. So you can just, the purpose of showing all those stuff is just to show you that those properties can be drag and drop on those fields, right? So going back to the naming convention here is I can just drag any properties that I want, and I can actually cascade those properties as well. So if you want to add hyphen in between, or underscore, or even plus, anything that you want to do, that is supported within the OS system to name a file. You should be able to bring them here, right? So again, if you want multiple iProperties as the name of your NC1 file, this is where you just do that, right? So you just cascade your multiple iProperties, and you just say, okay, you know what, I want dynamic naming, right? But again, as I said, for this whole presentation, I'll be staying to the part number. At the same time, you can also dictate where you want to save those files, right? So it's going to be most of the time you're probably going to be saving on your server where your job is, or this is where that you can access your NC1 file from your CNC machine directly, right? As you see on this presentation, I'll be saving all my files on my C drive, and then I have a DSC folder, and then I have an Inventor folder, right? And this is where I'll be saving all those files. Okay, and then what are you going to be doing, like in all those NC1 file that you're going to be getting and fed it to your machine directly, right? Going back to my settings again. So once my part settings is done, then I'm going to be moving on to my probe links again. One of the things that I before I move on, I wanted to let you know is, like, the purpose of doing all those properties would be like more automation, right? So especially like if I want to grab the shape size information from my properties, it's also part of the automation as well. So if you want to get things done fairly quickly during the conversion process, like as much properties that you have, including the shape size information, that will be very helpful, right? So what we do is, like, when we look into a part, the first thing that the software will be looking into is, like, how you're positioning your profile plane, right? So again, we are talking about automation here, right? If we want to try to achieve automation, I mean, like, we want to quickly create an NC1 file, right? Then we can very easily, I'm just going to choose a pen color over here, and I'm just going to grab that. I want to draw something quickly over here. So let's say, for example, we are talking about that I-beam over here, right? And we are on, let's say, for example, we are over here on the XY plane, right? Again, gentlemen, we are talking about automation here, right? So if we want to create, create NC1 file fairly quickly, this is what we want. We want on an assembly level, right? So I want, let's say, for example, we are talking about a channel. I want to place that channel as a C on that plane. It could be placed anywhere on that plane. Doesn't matter, but it should look like a C. If I have something like I've been presented like this one, right, then I can still work on it, but I have to do an additional manual input that I have to give is through that button over there. So I have to manually set the orientation for that. But again, if you put it like this as a C, then our conversion process would be much faster, right? The same goes for your other profile types as well. If I'm working on a rectangular tube, for example, I'm going to be putting my long hand standing, okay? So it's going to be always on the vertical side. The same goes for your unequal angle, right? So the long hand should be standing, as you see here. Sorry, I'm just trying to use my pen very quickly over here. Anyway, so it's an unequal angle. I want to see the long hand standing as well, right? And your I-beam should look like an eye on that plane. So we call it like, call-eye approach, so C-O-L-I, right? So if you put your profile plane, profile sketches like this on an assembly level, for example, like then creating NC1 file for the whole entire assembly would be very easy, given that you have given us the shape size information as well on the properties, right? So within one single click, I will be able to process the entire assembly and create NC1 file from there. So again, this is a requirement for automation. If you have something done out of this this call-eye approach, then we can still work on it, but we have to work them on a part level. We have to open each and every part and have to manually set the orientation in order to convert them to NC1 file, right? So like that pretty much it when it comes to like the requirement wise. So your first requirement is how you're positioning your profiles on your sketch plane, and your second one is your shape size information. So as I said, is like as long as you have it on your eye properties, I can grab it through my property reader as I showed you before. I'm going to drive you through one more time for those for that options there. So if I have my eye properties there, so what's going to happen is through that eye property reader, I'll be getting those data from stock number. So one of the things that I forget to mention is like remember that call-eye approach that we just talked about. This is by definition if you're using content center items, and at the same time if you're using frame generator, then all of those parts will be ended up anyway on that XY plane, and they will be exactly like C, O, L, and I, right? So you don't have to worry at all. So if you don't follow those design process anyway, like even if you just have your manual extrude you just plain you use a plane randomly and use extrude from the scratch, you can still the same logic, right? As long as they are on the same plane, all the parts on the same plane, and then they're like like COLI, then we can fairly quickly create NC1 file. But as I said, like if they are not, then we'll just rotate our plane, and then we can create NC1 file from there as well. So I'm going to be showing you an example also if something is not as per the COLI approach as well. Okay. So one of the things that I was talking also is like how we can map your shape size, right? As I said, like I'm going to be looking at in one of your iProperties. So on my examples over here, all my shape information is by default, as as I told you, like if you're working with content center stuff, they normally end up on the stock number, right? So I'll be grabbing that data from there. So let's say, for example, if you don't have the data, that shape information on your iProperties, and you want to work on a part level, then you can come over here also, like the software comes with the shape catalog, and then you can move on to different profile standards, right? So we have different library like DIN library here, and then different profile codes as well. Like let's say, for example, if I'm looking at a tube, so this is where all my tubes on the DIN library, right? So if I go back to the Imperial library, for example, if I'm looking into I-beam, for example, the BIMs, right? So this is all my BIMs over here. The S BIMs there, W BIMs there. All I have to do is highlight that BIMs and double click, and then the software will take it for that single part. But on my examples, as I told you, like I'll be grabbing everything from my iProperties, right? So so again, like the software comes with that catalog, so you will have it on your like it will come as a CSV file, and you can actually open those CSV files and edit any members that you want, right? And you can also edit if you have to add any members that is not within the library, for example. So like you can create your own size. So what I'm trying to say here is like you can have your custom sizes even, not the custom types. So at the end of the day, it's going to be your channels, tubes, and angles and I-beams, right? For the shape sizes, right? But it could be a difference, even non-standard sizes. We can still work on that, right? So as I said, like you can define your thing, so you can give it a name, a group where it belongs to, the standard types, right? And the profile code, right? Depending on the profile type, and your height, the width, and your field radius. You can ignore that. You can put it to 0. All we need is those 4 parameters correctly. Your height, profile width, flange thickness, and web thickness. Those thicknesses are very important for the bevel description, right? So if you have it like wrong data on those thicknesses, your bevel will be wrong, right? So over here, as I talked, as I mentioned, like you can add new members from here as well, right? And one of the last option is like let's say, for example, you're working on a part, and the size information is not on your iProperties, and you don't want to go ahead and find it from the catalog, but you know the size anyway, right? So let's say, for example, I want to add this one here. I can just quickly click on Quick Add and type my size over here, 1022, for example. If I have the size exist on the library, then the software will take it and it will not complain at all. So now, going to my example again, to convert that NC1 file, the first thing that I want to mention is like you are working on a right orientation. Remember that we talked like we're going to be following the automation, right? So you can looking at all those sketches on the front plane, right? And I want to read anything that comes with marking, anything that like if I want to read embossing feature for the marking for the stamping as well. And if I have any bending content, sheet metals, I want to read that as well, and I want to read bevels as well. The reason why it's there is if you need them for your machine, for your machine, then you can keep them checked. If you don't need them, if your machine doesn't do any stamping, for example, you can uncheck it. If your machine doesn't do any bending, you can uncheck it, and the software will not bring those details on your NC1 file. So you can still have those details on your model, but the software will not bring those details on the NC1 file level, right? The same goes for your any feature which is not if it's suppressed, the software will not bring those on the NC1 file. So what I meant by that is our software is not feature dependent. it is not feature based. As you see, you can push it, force it to be feature based for the drilling detection, right? But the software will not look for features at all. All it does is look for a face. So it reads your faces, and from there it decides whether it's a drill or something else, right? So the reason why I'm telling this is is because of the technology that we are using to detect our operations. So you're allowed to suppress any components that you don't want. So if you suppress anything, it's going to be gone from that face anyway, right? So the software, when it's analyzing the face, it will not see those operations. So it will not bring any NC1 files. So again, if you have suppressed members over here, suppressed features, they will not show up in the NC1 file. Okay, so and this is a one-time settings again, right? And I'm going to turn on also remember that I said I can also create a part stamping, right? So I'm going to be grabbing your part number and putting it on a top flange, and I have positioned that stamping on on an X and Y direction with 2 inches, and with the height of the text with 2 inches as well, right? And then once I do that settings, all I have to do is save and exit. And this is a one-time settings that you have to do, gentlemen. So once you do that, all you have to do is you come over here and you do nothing, right? You just make sure that the software is the part is on the XY plane, and you have the shape size information there, right? All you have to do is open that part and click on part DSTV. So once you click on that, the software will show up within the DSTV window over here, right? At the same time, you have a warning window over here. So if you have anything missing, let's say for example, the orientation was not right, and at the same time, if you don't have the shape size information, which is going to be happening if you're working with step files, for example, most of the step file will probably not have any kind of data for shape size. Then if you try to use that conversion from here directly, the software will give you a clue. Hey, I don't have the size. Can you give the size information, please? Right? And as you see over here, as I mentioned, this is going to be your DSTV window, right? And remember that we talked about where those files will be saved. So if you just take a look over here on that file over here, so you have that NC1 file being created over there, right? If you just double click with and you try to open that with Notepad, you can see that NC1 file with Notepad as well, right? If you just scroll down a bit quickly, remember that I said we are doing our stamping for the part number, right? We are grabbing that part number and we are putting it on a default position of 2 inches, which is 50.8 millimeter and 50.8 millimeter, and the height of the text is 2 inches as well, right? So what's going to happen? The machine will etch the part number on the top flange on that default location, right? So once you open this, create your NC1 file, we will provide you with a viewer. So as you see, you're looking at a CMS viewer, and you can download it from our website. This is pointing to a different path, so I'm just going to go to the right path, which is the Inventor, right? So I'm just going to the DST folder and then Inventor, and if I hit OK, I'll be only looking at the NC1 file we just created. So that's the NC1 file that we just created from that part there. So if I just compare that quickly, as I said, we had 2 clips at the 2 side, right? And we had 4 drills on both corners in total. So if I just take a look over here, and if I just click on my shape lines to remove that, so then I can see only the CNC lines here. So that box over there is actually showing you the part number stamp, right? So if I just go to the view over here, then this is where I can see the actual view, right? On the 3D view, I will see it as a black box over there. Okay, so this is what it involves to create an NC1 file from a part level. So let's say, for example, if I want to create create something for channel, it's the same story, right? Just for visual purposes, I'm just going to go to its profile plane. As you see, it's on the XY plane. That's look like a seat. Is exactly what we want. And at the same time, if I just go to, as you see, it's the frame generator part. And if I go to I properties over here, and if I just try to see for the stock number, as you see, I have that size here as well, right? So all I have to do is just click on DSTV, and within seconds, as you see, you have your NC1 file already here over here. By the way, if I just come back to my properties over here and take a look here. So the first line was my part number, so it's coming in this line over here is a part number, and the next line was the revision number. So we didn't have any information on the revision, so that's why you see there is nothing, NA. And the line 2 description again, right? and then line 4 was part number. So as you see, this line 1 and line 4 is identical over here, right? And then we had a material which is sheet metal. I'm sorry, steel, a mild steel. So that's what it's capturing over here. So you know those lines, drag and drop, and based on your mission requirement. Okay. Now I want to move on to a part that add some additional feature over here. The reason why I'm showing you that is for this one here. I'm just going to say look at where's my cube there. There you go. That's the cube that I was looking for. Sorry, I missed that part. Did I close it? No, it's here. There you go. So I want to go to the right face and just want to show you like what kind of operations that the software can handle. So if you just take a look over here, as like, and if I go to the modeling tree here, I see one of the things over here is embossing feature, right? So I expect to see an SI block coming from the embossing on the front web, right? At the same time, I see that I have sketches over here, and unused sketches. As I mentioned before, I can bring a scribe line and any sketch line as a scribe line, given that the scribe line has not been consumed. And on top of that, you might have like few unused sketches, like, right? And the software doesn't know which one to bring. So there's a reason why you have to do like what you have to do. You have to highlight those sketch and format it for your scribe line that you want to bring it as a scribe line, right? The same goes for the pop mark. So let's say some people doesn't like, and most of the time I see that like you want to minimize your operation time, right? So instead of etching the whole lines, you want to put in a line for like start and end line for this channel, so that your welder can come and weld the channel over here, for example, as a rough example, as you can see over here. So if you want to bring those points as a pop marks, then you can also do that. So you can highlight that and hit it as a pop mark, and then software will bring them as a pop mark as well, right? So as you see again, I have a cope over here, a cope fillet. So I have a radius involved over here. I had some drills and slots, and at the same time I have a miter. So due to that miter, I will be expecting top and bottom flange. On the top and bottom flange, I'll be expecting 2 bevels, right? So the software should also get those bevel descriptions over there as well. So all I have to do, as I said, like I click on part DSTV, and then voila, so you have your NC1 file over here, right? So I'm just going to go back to my path over here, and just to show you that NC1 file, and then with a notepad, right? Because as you see on the viewer, it's very limited view there. So I wanted to roughly show you that's your edge preparation description on the top flange. At the same time, on the bottom flange, some edge preparation description over here, the 45-degree bevel that you see there, because I had a 45-degree miter on the part, right? And if you scroll down over here, I see a slot on the top flange. I see a couple of 4 slots on the web. At the same time, I see 4 marking content over here. The the pop marks there. So that as you see, the diameter of those drills are 0, so that means it's just a pop mark, right? And I got 2 SI blocks. So as I mentioned, like I have one on the front web, which was the text stencil, was embossing, right? So we grab the location of the embossing from your feature, and we also read the data height of the profile as well. I mean height of the text, and we put the text over there. And this is the default location of my stamping feature. So where you don't do any kind of embossing because you don't want to waste your time in doing that. All we do, we grab the part number from your iProperties and we put it on a default height and with the default location. Remember that we did it 2 inches. So as you see, 50.8 millimeter is 2 inches. So you have those X and Y Cartesian values, and at the same time, the height of the text was 2 inches as well. And at the end, we have 3 KO blocks. The KO block stands for your marking lines, right? So we had 3 lines on this marking sketch, right? So that's why you see the three KO blocks there. So if I open that NC1 file, if you want to have to refresh the path, all you have to do, you copy the path from the viewer, and then you just paste it again. So if you Control-C, Control-V on that field, will just refresh all those NC1 listed over here, and then you can just go one by one and verify them. So if I remember, the last one was CMS 12301. So if I click on this is what I see. So remember that I said like embossing feature is bringing that on the front web, so which is for the text stenciling, and this is the marking content as you see for the channel there, and then I have that 4 tiny dots there for the pop marks, right? At the same time, if I just go to the front top flange there, so that's the stamping that I am doing from my stamp reader. I'm in, yeah, a default stamping tool, right? So it will grab your part number and put it on the default, which was my top flange, and it was with 2 inches height, and we had a slot on the top flange as well, right? You know, if I don't want to see my black lines, which is the lines of the actual part, which is you know, W8 by 31, the actual size of the part, and if I just remove click again, so it will just show me the red lines, which is the CNC line, which is the cut lines, right? So as I see over here, that the you know, the software will also able to capture the bevels, so those triangles there. So it talks about, like, you know, it's, if I just highlight this one, you know, it's just gonna also supposed to, okay, we are on a viewer, that's why it doesn't show it. But you know, as I mentioned, like, you know, we have a CMS standalone software, right? So that software you can use that to open anything and edit anything, right? Let's say, for example, if I just open that part we just created right now, this one there, right? As I mentioned, like, you know, if I have to edit anything, then I can do that over here. So I can just, you know, highlight a feature that is wrong, for example. So let's say for this one here, if I just click on here, so it will show me, like, you know, what kind of bevel is that, right? And if you want to edit something or clean, you know, delete something, so you can just hover over your mouse and the software will delete it as well. So as you see, those bevel is gone over here. So, like, you know, the same thing on the bottom plate as well. As you see, I just got rid of the bevel because my machine does not do bevel, for example, right? So, you know, this can be used as a quick editor, and you know, and you can create your NC1. I mean, oh, I'm showing you from the viewer again. I was trying to show it from this over here. So there's 2 different tools over here. As you see, this is a viewer, the free tool, and this is an CMS standard that will allow you to edit your stuff as well. So if I just click it again one more time, as you see, I have that, you know, for example, roughly I want a 35-degree bevel, for example, I can just change it. So once I do that, you're gonna see that on the DST as well. That things will be changed here as well. See that this is a 35-degree angle there right now. Okay. So this is an, you know, and then if I don't want this bevel, for example, right? And as I said, like, and I can hover over my mouse and then delete the operation that I don't want, right? And then the NC1 file will be updated as well. As you see on this EU, there is no bevel descriptions like those ones. Okay, and then once I do all those edit, and let's say, for example, as I said, like, you can add it, you can do the edge preparation, like, you know, fairly quickly as well here. So let's say, for example, I want to do the edge preparation on this side here. So I can just select the start point and the end point, and the software will give me an option to like, you know, what kind of bevel I want to apply. So I can do, like, you know, top and bottom bevel, you know, semi bevel and double bevel as well. Anything that you want to like, you know. Let's say I'm going to go with a 15-degree bevel over here, and I apply that one. So once I do that, I know it was done on the bottom flange. If you just take a look on the bottom flange here, so you can see that something has been changed over here, which is this one over there. So this is talking about the bevel descriptions over there. So this is a CMS standard window that can be used as a post processor if you need it to be, or at the same time NC1 editor, like, you know, if you have something from Tekla or NC1 that you want to correct, delete and then correct and apply new stuff. This is where you can come and apply new stuff and create NC1 file from. On top of that, as I said, like, in this tool can be used to create NC1 file from scratch as well, right? So I'm going to go to that and just show you that as well. See, what I did, I just highlighted that the part size and kept the length as it is, and double clicking will clean all the stuff and can bring it to a clean part, right? And then let's say, for example, if I go to the operations and come to the standard, and I want to clean, you know, apply you know, cope, for example, on that corner over there, right? Or like in anywhere, right? You know, let's say, for example, I want to put it on the flange even, right? So if I put it on the flange, for example, in this corner over there, you know, and, you know, 2 inches by 3, and I'll put, like, you know, 0.5 roughly, you know, and then if I apply that, as you see, like, you know, this is where that the cut is there, right? And at the same time, if I just want to do other operations, let's say, for example, a miter over here on that corner over there, I'm going to put it on this time on the web, and I'm going to put it on this, well, put it on the top left corner over there, right? And let's say, for example, we want a 35-degree miter, right? And then if I just do that over here, as you see, this is what been done over here. Well, you know, these are quick operations that you can apply in that, and then you can send it to your machine directly. Anyway, let's move on to our Inventor again. So now that we covered, like, different type of profiles, when it comes to the single parts, I want to show you some of the functionalities on the sheet metals as well. So as you see, as I told you, like, creating NC1 file from sheet metal is very straightforward. All you have to make sure is, like, if you go to your flat pattern, they're actually on the XY plane. That's it. That's the only thing that you have to confirm. So once you have done it right, all you have to do is, like, you don't have to go to the flat pattern at all. So you just open that part and you come to the CMS and heat on part DSTV, and then your NC1 file is ready to go over here as well. See that? That's that fast, as you see. So I have those that NC1 file being created over here, and with the KA. KA stands for K stands for your bending lines, right? So remember those bending lines there. So it's actually gives the coordinates of those bending lines and the rotation angles and the radius of the bending as well. Okay. So if I just try to see that on my NC1 file, on my NC1 viewer, which is CMS viewer, it will not show me the bended part. This one's over there. And one of the things that this is the big line that showing up over here because it's coming from my default stamping. If I don't want that, as I said, like, and you can hover over that and press delete, and this is going to be gone. And those are the lines, as I mentioned from the very beginning, is like, this is your marking. So your bending operations. If your machine can handle that, then you can do the bending from here as well. Okay, so let's move on to another example over here for this EV shape here. Well, this is not that's been created as a sheet from the sheet metal, and this is an example from one of my clients here, and then they're doing, like, they're creating a EV, an universal beam from sheet metal, right? So if you want to do, like, regular sheet metal stuff, like, only as a plate, then you can easily create an NC1 file with just one single click. As you see, it will just do that with one single click. And if I just go to my target folder, and if I just take a look in this one here, so as you see, it lists all those BO. There you go. See that? So with one single click, and also bringing that default stamping on the KA, which is the bending lines. Okay. But the one of the things that I want to show you is also, like, it's like, you can treat sheet metal stuff as a shape size. As a shape as well. So this could be an example over here. So this example, I can just show you for two different purposes. The first one is, like, is that, like, it's an angle, as you see. Even though it's sheet metal, we're going to be creating that as an angle, as an L profile. And I want to treat it as, like, as you see, it's not an L on a single plane, like, right? Like, let's say if I want to put it like an L, it's actually not something that our software is configured with, right? So as you see, like, as I said, like, and if something is not as per the call-eye approach, which the software looks for when you want to process everything on an assembly level, then it's looks for everything on an XY plane, for example. But we're going to be doing that on a custom level because it's not exactly the call-eye approach. So all we do, we come out of here and we click on set orientation, right? And then once you click on this, take a look over here, it becomes front, right? So just like, visual confirmation that the clicking button works at the same time. At the same time, if you go to your iProversal on the custom, you're going to see that you have some data has been added. So it's coming from that click there, right? And then all you need is the same thing is your shape size information. So I'll just use that example as well, like for quick add functionality as well. So if I just try to add the size, I know it's an 2.5, and it's an equal angle. So it's a 2.5 and 2.5. And I will say, like, thickness with the quarter. Okay. And if I hit OK, and the software will take it because the size exists on the library, right? And if I just run that over here, part DSTV, and boom, there you go. Take a look over here. So the software actually detects that it's a sheet metal. It gives you a warning. Hey, this is a sheet metal, but you created that as a part, so just watch out, right? It's a warning, not necessarily an error, right? So if I just try to see that NC1 file on my viewer over here right now, copy that and refresh that one more time. So as you see, this is a stamping that been coming outside. So even, like, on the NC1 editor, you can reposition them as well. Okay, and here you go. So you see that, like, so you have that sheet metal thing been created as an angle, and we were able to create an NC1 file for an angle as well, right? If I go back to the previous example here, even like this one here, even like if I want to try to create an NC1 file for this one, treating it as an angle, I mean as a beam, I mean as I'm losing the term, as an UV beam, right? Which is an I beam, right? So all I need to do is like put it like an eye, right? I was just looking for the cube there. Hello. Where's my my cube go? Okay, maybe in the 3D model. Oh, there you go. Yeah. Sorry, I'm just being so old school here. Anyway, so all I do is I come over here, I click on set orientation, and I just need to give it a size, right? So let's say, for example, I want to do that. I don't have the exact size for this one. Remember that we already created an NC1 file as a plate, but this time I'm going to be creating an NC1 file as a BIM, right? So I'm going to get a random size from here. Let's say, for example, it's a DIN shape, and I know I'll treat it as an I-beam, or maybe it's it's a British shape actually. So it's an EB, right? So I'm going to go with I and EB, I don't know, like some. So I'll just take a random size from here. Okay, let's just take this one here, right? So as you see, you can highlight anything. Well, just one quick note over here. So if you add any wrong size, the software will not give you a clue that you have selected the wrong size. The only time that it will figure out that it's the wrong size is when you go ahead and verify that with the viewer. So I'm just going to run that NC1 file anyway. I'm going to okay, it's not sheet metal. As you see, it's detected the sheet metal, and it didn't like the output here as well. So I'm just going to regen again one more time where that settings was done correctly. Let me just go back over here on the XY, and I run that again one more time. Here you go. So it did create some face over here, as you see, treating that as a BIM. But if I just go ahead and try to see that on the viewer, I'm going to see that I've selected the wrong size. So I'm going to go back to the 7 again. So as you see, like it's treated as an EV shape. But if I just go to the front face view, as you see, my red line and the black line is not matching. Again, the red line is the CNC line where the machine will cut stuff, and the black line is the actual profile height that we are feeding to the machine, right? So if they don't match with each other, so that means like either there's a discrepancy or there might be a cut inside. So we easily know there was no cut on the web, so that means it's the wrong side that we have selected, right? So again, the software will not give you a clue if you select the wrong size. So only time that you can verify that a wrong size has been selected is when you visually verify your NC1 file quickly. Okay, this is a manual QA that you have to do. Now we will jump in to just want to show you a quick example that the software can also work with step files fairly easily. So I'm just going to go ahead and find some step file, for example. And not necessarily have to be, let's say I'll just take this, the already example that I have is 1430. Okay, so if I just open that, I'll just see it. Okay. So here you go. As you see, like this is a totally solid body, no feature whatsoever. All I have to do is I come to the right face, or any face that has look like an eye, right? And one of the things that you have to make sure that's like if you're working on when it comes to the working on a sorry step file, and you not necessarily can guarantee the same face, right? So for this purposes, for this point, I will come to the custom. I'll click on this, okay, and I'll click on. I'll take a look. Once I click on set orientation, it will come front, and at the same time, I'm just going to give it the profile size. As you know, like it's not going to be in my iProper, so I'm just going to do it manually over here. 1430. So this is a quick click from here, and quick click for adding the size, and then boom, you click on over here, and then this is your NC1 file for this new one, that part there. So if I just try to show you that part from that viewer over here, seeing is believing, so it's better to see that. I think it's the part. No, not this one. I'm gonna take a look into that. So this is the one part that we just created here. See that? So it was able to capture those scope very clearly. As you see, it's just overlapping. As you see, like the stamping, because as you remember that I have a stamping default stamping, right? So if you don't want the default stamping, all you can do, you come over here and I'm going to turn off the stamping. I don't want that. And if I rerun that, I'm going to have a new NC1 file. And if I go to the viewer and if I click again, and that thing will be gone, as you see. And then if I just remove the shape lines, I just want to see the my CNC line. As you see, that's a clean representation that we had, slot been even captured correctly, as you see. On both sides, so all our portions have been captured with one single click, as you see, right? So it's very straightforward, even in working with step files, right? Now I'm going to be jumping on and show you a couple of examples to assemblies here, right? Well, I was expecting to finish it by 45 minutes, but it's staying on some extra time here. But I'm going to be fairly quick over here. Once we come to the assembly level, that we can work on some different settings here, right? So I can work on some selected members. So as you see, over here, I have sheet metals on the assembly, but those sheet metals are, for example, it's not supported by machine. So I want this NC1 file only for some selected items. So I can go ahead and select the members that I want to bring to us. So I'm going to be old school over here to just to show you, gentlemen, that I'm actually selecting the components, right? And then working on those components, right? And as you see, I have two different occurrences for the same size, right? The software will realize that, and it will not give me 6 NC1 files. It will actually give me 3 NC1 files. So if I just do that right now, click on DSTV, there you go. So right now I see that there is some error. So the software gives me an indication something was wrong. So remember that, take a look here. So it says looking for a settings orientation, set orientation was set to custom orientation, right? So that means that's not going to work because I know we are working on an assembly and we need the settings for a default positioning, so which is going to be XY, right? So we're going to come back to the XY and rerun that process quickly again, right? And then I can DST for the selected ones. And there you go. See that all those errors are gone, and I have 3 NC1 file over here. So I can just, what it does is on the target folder, if I just go back to my main folder, it just creates a new folder, exactly the same name as your assembly name, right? And then it dumps all those NC1 files from that on that folder, right? Just to verify those NC1 files, you can just copy that path again, and you can come to the viewer and put it over here. And we can just take a look on those 3 NC1 file that we just created, right? Those are, as you see, those are matrix shapes, right? So, fairly quickly. Given that you had the shape size information was there, and all those components were placed as per the call-I approach. The same goes for, let's say you want to work on an assembly, a fairly, let's say slightly bigger compared to the one that we had before, and you want to make sure that's you want to create NC1 file only for the items that you want, right? So for that purpose, what you can do is you can select members and click tag, as you saw over here. I can click tag, or what I suggest is once you work on it, I want you to where's my part? It's probably at the end. I'm going to open that part anyway. And then I want you to, or you can, create a custom property, which is DSTV_tag, and you set this value to yes. Then what's going to happen is, the software will process those parts only where those tag is set to yes only, right? So if I just come back to this, my assembly again, which is, I believe I put it on the very beginning, so mezzanine over there. And let's say, for example, if I click on DSC for the tagged items right now, so I want to process only my BIMs here right now. I don't want my clips to be converted, or my tubes, or my plates to be converted. Then I can just do it like this. So that the software will show you which materials has been highlighted, and as you see over here, it's also will show you how many parts are being converted right now. On top of that, the software has also capacity to understand which members has multiple patterns. I mean, occurrences. Let's say, for example, as I said in the very beginning as well, the software will not bring NC1 file, 3 separate NC1 files for these 3 components. Instead, it will give me just only 1. Okay, so as you see, for that very reason, even though we were processing 38 parts, it's ended up giving me only 29 NC1 file with the conversion report. So if anything failed, it will show up over here, right? But it's clean, so that means like everything was converted. And as I said, like it did recognize like multiple occurrences, and it will only bring the ones that you need. Okay. On top of that, like the software, our software can read your can read your I don't know why it's keep popping up on the other side. I'm just trying to grab my other one over here. Just bear with me. Just gonna take a quick second here. Here you go. Yeah. So so if you want to work on an enter assembly, right? And if you have an active bill of materials, for example, like let's say if I go to manage and have a bill of materials here, and those numbers from there, the quantity, even that's not necessarily have to be numbers, could be in inches and anything, that will grab the details from your iProviz as well. I mean on your bill of materials as well. So for that considerably manageable assembly, I want to process everything entirely, so I can just click on DSTV over here, and as you see, with one single click, it's actually processing 77 parts in one single click, right? And all those parts will be converted within less than 1 minute, right? So as you see, I have like a couple of these are not errors. They're kind of in warning. So like we put it over there for debug purposes. But as you see over here, all parts has been captured, right? And if I just take a look over here on the bill of materials, and as I mentioned here, like you don't have all those 77 parts, because most of the parts are like it's pattern and occurrences. Multiple occurrences, right? So if I just go back to this this bill of materials again one more time, so over here, so let's say for example, if I'm looking at the PL01, I expect to see an 8 over there, right? So on the quantity side, so I'm going to go to that folder over there and take a look on PL01, which is this one. And if you take a look on this one there, here that tiny 8, which talks about the quantity on this part, right? The same goes for your other members as well. So if I'm just taking a look into, let's say for example, B03, I see that like 249.25, right? So B03, if I just open that one, I see the quantity is 2. So that means the part that I have, which is the length of the part, is actually half of this one, right? And that does, you have two the quantity is set to 2. And by the way, as you know, there's all those parameter in this NC1 file is millimeter. So this is 3,165.48 millimeter would be like some inches. So I'm just gonna roughly, I think it should be 124 inches, something like that. So 3165.48 divided by 25.4, right? You make it inches. So yeah, as you see, like 124. So which is like half of like times 2. So which is like a 149.25. It's very close, as you see right now. See that? So exactly 2. So the software will capture your quantities from your model directly. So yeah, that's pretty much it that I wanted to show you today. And we can zoom almost the whole time. And if you have any questions, just let me know.
All right, gentlemen. All right, Mahbub, thank you for your presentation. We'll open the floor for your questions, and I believe we already have a question from Pedro Munoz. The question is, can you export the 3D model to a 3D PDF file that can be rotated, zoomed in, panned, or measured?
No, our software does not. It's only dedicated for NC1 file. There is no way that we can export to PDF.
That answers your question. Also, as we wait for other questions to come in, as a reminder, the recording of this webinar will be emailed to you, and you can also view this recording on our YouTube channel or our social media accounts such as LinkedIn, Twitter, or Facebook by 5:30 p.m. EST tomorrow.
Okay, I don't think we have any other questions today.
Right, that looks like a wrap for today. If you did have any follow-up questions at a later date about this presentation, then feel free to reach out to us at info@structsoft-solutions.com, and we will be happy to assist you. And having said that, I'd like to thank you for joining us today, and we hope you have a great day ahead.
Bye, everyone. Well, Pedro had another question, so I'll write it to Pedro. Okay.
Okay, sounds good.
Okay, cool.